Welcome aspiring data scientists and welcome future Python programmers. Today we have a look at Numpy, but more on that later. The learning goals for this part of the introduction course to Python will be overall knowledge and how we can work with Numpy, then subsetting of Numpy arrays through normal applications and also via operators. And then in the next presentation, we focus on multi-dimensional arrays, how we can subset those, and how we can apply Numpy methods to receive basic statistics. The content of today is to get a knowledge about Numpy. After that, we do subsetting of Numpy arrays, and in the end, subsetting via operators. So, first of all, what is actually Numpy? For that, some definitions. Numpy is a program library for the programming language Python. Many things are pre-coded so that you can code faster and more effectively. Numpy extends Python with functions for scientific computing and numerical calculations. So in short, we can just say that Numpy is an open library to which we can have access. In this library are many pre-coded functions and methods that we can basically steal from that library and apply it to our own code. So as always with Python, almost all problems were faced by someone else already. So if we Google around a little bit, we can often already find the solution to our problem. And if someone is really good, he puts all these different solutions into one library and provides it for the rest of the Python programmers. How do we get access to this library? We do it by importing it into Python. We do this by writing into our Python shell import numpy snp. The first part imports numpy, and the second part actually defines that if we write np dot something else, that Python can understand, okay, now Python will have access of the Numpy library and will use a certain function or method from that library. Let's make a short repetition of lists. First of all, they are useful because we can collect multiple values in them. We can also add, replace, delete, or select multiple elements within a list. The huge disadvantage, though, is that we cannot make simple calculations with them. For example, here I would like to actually multiply each individual element with the representative element of a different list. If I try to do this, so I multiply price by quantity, I will get an error message. Why? Because we cannot use those operators on lists. But we can do this on Numpy, and that is why Numpy is so important for us. So, in short, Numpy is much better at using arithmetic operators than lists are. Overall, we could say from now on that most of the lists that we use are replaced by Numpy arrays because we can just work much more flexible with them. Overall, they give you fast and easy calculations. The only disadvantage of Numpy is that you can only have one data type at a time in one Numpy array. Now let's have a side-by-side comparison of lists and Numpy arrays. The left-hand side is already quite familiar to you. If we print out our both lists, we can see that beginning was defined by squared brackets and the comma are the separators of each element. Now we import numpy snp in our first line, and then we actually create two new variables, np price and np quantity, and store our Numpy array inside of it. And we can create a Numpy array by calling our np.array function onto our lists, our previous lists. This tells Python that he will change the type of price or quantity from a list to a Numpy array. Now, if we print it out, we can see that the beginning and ending of those Numpy arrays are still defined by squared brackets, but the separators are no commas anymore, they are spaces now. That is how we created our first two Numpy arrays. Let's have another example of NumPy and how we can make simple calculations with them. In the beginning, we wanted to multiply each individual element of the list with the representative element of the other list. Now we can actually do that. Why? Because we transformed our lists to NumPy arrays in the first 2 lines. And because we can actually multiply the individual elements with each other in NumPy arrays, we can get our new variable called revenue, which is the multiplication of each element with the other one. So if we now look onto the table on the right-hand side, we multiplied these 2 values and these 2 values and these 2 values and always got a new result below. Subsetting for NumPy arrays is quite similar to lists. It's basically the same, I could even say. If you want to search for something, you can do this by the index number. The first element has index number 0, so we still keep 0 indexing, and the rest goes so on. Also, you can select ranges in NumPy, and you again do this by using the double points and defining a range, and again it's there inclusive and exclusive. Finally, what is very useful with NumPy is you can also subset via operators. So here in this example, we would like to store all elements in a new variable called above 200 that are values above 200. How do we do it? First, we access our NumPy array called revenue. After that, so Python knows already, okay, we want to have something from the variable revenue. And after that, in the squared brackets, we actually define our argument. Meaning, in this case, we define, okay, we would like to have all elements in the list that are above 200. So all elements in our list revenue that are above 200 should be in our output. Now we apply this, and as we can see, 350 and 273, both are above 200, are in our new output. Here in the end, we have a slide about the comparison operators. I will not go too much in depth into them, so just have a look of them by yourselves, because I'm pretty sure that you know most of them already, and also the logic behind them. Congratulations, you have finished another Python online video. This time it was about NumPy, and we are looking forward to see you in the next video. Goodbye.